Alright, I'm going to be going over the quiz review for 7.3, which is rational exponents and radical expressions. For this first section, we are going to be writing each expression in radical form if it is an exponent, or we're going to write each radical in exponential form. So we're not simplifying anything, we're just writing it in a different format. So for this first one, I have the square root of 13. When I don't see an index or an exponent, we can assume the exponent is 1 and the index is 2. So when I rewrite this, I'm going to have 13 to the 1/2 power. Over here, I have the square root of 37 cubed. So when I rewrite this, I have 37 to the 3/2. This one, I have the cubed root of 17x. Now, everything under this radical symbol is being cubed. So I need to use parentheses when I write this. I have 17x. All of it is being raised to the 1/3 since there's no exponent over here. 7ab, this is all being raised to the 4/3, so I'm going to put all of it under the radical. 7ab. The root is 3, and this entire thing is being raised to the 4th power, so once again I need to use parentheses there. On this one, I have 21z to the 1/2. The only thing being raised to the 1/2 is the z, so the 21 is going to stay out, and I'm going to take the square root of z. And then here I have 13 times ab to the 2/3 power. This 13 is not included, so I'm going to leave it out. And then I'm going to put the ab under the radical. This is a cubed root, and it's also being squared, so I need to use parentheses. If I were to just put my squared, like if I were to write this, like this, the cubed root of ab squared, it would look like only the b is being squared, which is wrong. That's why we have to use the parentheses on all of these. Alright, so moving on to the next section, we're actually going to be simplifying now. So we're going to be taking out factors to simplify each one of these. So I have 1/81 to the 1/4, so the first thing I'm going to do is convert this to a root. This is the 4th root of 1/81. When I take the 4th root, or the root of a fraction, I have to take the 4th root of both the numerator and denominator. So the 4th root of 1 is just 1. And then on the bottom, I'm going to need to factor this out. So 81 I know is a perfect square. 9 times 9 equals 81. And then 9 is also a perfect square, which factors down to 3 and 3. So what I have here is 4. Since I'm looking for groups of 4, I have 4 3's. So I can take out a 3. And I'm left with the fraction 1/3. Number 8, I'm taking the 5th root of 32, which means I'm looking for groups of 5 within 32. So I'm going to start factoring this down. 32 I know is an even number, so I could divide it by 2, but I know that it is also divisible by 4. So I'm going to factor it down. 32 divided by 4 is 8. And this 4 can factor into 2 and 2. The 8 will factor into a 2 and a 4, and the 4 will factor into 2 and a 2. So I'm looking for groups of 5, and I have 1, 2, 3, 4, 5, 2. So I'm going to take out a 2. Number 9, I have 512 to the 1/3 power, which means that I have the 3rd root of 512. So I'll be looking for groups of 3 within 512. So the first thing I need to do is factor this down. It is an even number, so I know it's divisible by 2. But with large numbers, instead of dividing it by 2 first, I usually try something else like 8 or even like 16. So I'm going to divide 512 by 16, and sure enough, it does divide. I get 16 and 32 as my factors. I'm looking for groups of 3, so I'm going to keep going. I know 32 divided by 2 is also 16. So I have 2 16s, but I need 3, so I'm going to keep factoring down. 16 I can split into 4 times 4, and this 16 can split into 4 times 4. So if I'm looking for groups of 3, I have 1, 2, 3. I have 3 4s, so I can take out a 4. but I need to keep going because I still have a 2 and a 4. So the 2 is a prime number, so I can't factor that anymore, but this 4 can factor into 2 and 2. So I have 1, 2, 3 2's, and I also take out a 2. 4 times 2 equals 8, so my answer is 8. Number 10, we also have a fraction here, and I'm taking the 5th root of 32 over 1024. So just like we did on number 7, we're going to need to factor both the top and the bottom, and we're looking for groups of 5. So if I factor 32, I already actually did that above. I know it factors into 4 and 8. The 8 factors into 4 and 2. This 4 factors into 2 and 2. And this 4 also factors down to 2 and 2. So I have 1, 2, 3, 4, 5. 5 2's, so that is what my top simplifies to. I want to leave space to factor the bottom. That's the numerator. And then in the denominator, I have 1024. Once again, that's an even number, but it's very large, so I'm going to try dividing it by a larger even number, like 16. So I get 16 and 64. 64 factors into 8 and 8, while 16 factors into 4 and 4. These 8's factor into 4 and 2. These 4's factor down into 2's. And I do have a group of 5. I'll keep factoring though. All these 4's down into 2's. So now I'm going to see how it looks like I have multiple groups of 5. So 1, 2, 3, 4, 5. It's my first group of 2. Group of 5. And then I have another 1, 2, 3, 4, 5. So I'm going to take out another 2. So I have 5 over 2 times 2. And actually I just realized something. I did something that I've seen other people do. Is on top, that shouldn't have been a 5. I was looking for groups of 5, and I actually took out the number 2. So I should have a 2 on top here. So I have 2 over 2 times 2, which gives me 2 over 4, which simplifies to 1/2. Alright, on number 11, I'm taking the 4th root of 36a squared b to the 4th, and that's all being raised to the 2nd power. So when I have something like this where I am taking the root of something and then I'm also squaring it or cubing it or whatever, I can try and do what is in here first and then square it at the end. And if that works, that's usually the easier way, but sometimes that won't actually work. So I'll give it a try. So I'm going to try and make groups of 4 within these parentheses. So 36, 36 I know is 6 and 6, and each 6 factors into a 2 and a 3 and a 2 and a 3. Now, those are all its prime factors, and I'm looking for groups of 4, and I actually can't find any. So this is a situation where I'm going to have to back up, and I am going to have to use this power of 2 in order to get everything to factor out. So what I'm going to do is I'm actually going to distribute this to everything. Since everything's being raised to the power of 2, I can distribute that out and basically rewrite this as the 4th root of 36 squared, a squared squared, which would be a to the 4th, and b to the 4th squared, so 4 times 2 is 8. Now I'm going to factor this down, but I don't just have a 36, I actually have 2 36s because it's 36 squared. So each of these factor into 6 and 6, and then I can see that I have 4 of a kind, which is what I'm looking for. So I can take out that 6, and then I have a to the 4th, but the 4th root of that, so that would be a to the 4 over 4, and then I have b to the 8 over 4. Both of these will simplify to give me 6a, because 4 over 4 is just 1, b squared. And that's my final answer. Number 12, I will be taking the 5th root of 3,125. So this is quite a large number that ends in a 5, and I'll be looking for groups of 5. So anytime a number ends in 5, I know that it's divisible by 5, but this is such a large number, I might want to try dividing it first by another number I know is divisible by 5, like I could try dividing it by 125. And that does work. When I divide it by 125, I'm left with 25. And then I know 125. I actually know this is a perfect cube. 5 times 5 times 5. And 25 is a perfect square. So there I have my 5 5s. So my answer to this is just 5. Alright, number 13. Taking the third root of 1,331, j to the 6th, k to the 12th. So if it's the third root, I'm looking for groups of 3. This number, 1,331, it's not even, so I can't divide it by 2. It doesn't end in 5, and it doesn't end in 0. So those are my usual go-tos. And we could check if it's divisible by 3 or 9 by adding the digits. So I have 1 plus 3 is 4, plus 3 plus 1 would be 8. 8 is not divisible by 3 or 9, so those won't work. So my only options would be to try, usually at this point I'll try to divide it by 7, and 7 doesn't work. And if 7 doesn't work, I will try the number 11, and 11 does work. 7 and 11 are prime numbers, so which means that they can't be divided evenly by anything else. So if all else fails, you can usually try 7 or 11, and you can find a factor. So when I divide this by 11, I got 121. 121 is also divisible by 11, and it's actually the perfect square. So I get 11 and 11. So if I'm looking for groups of 3, I have them right here. 11 times 11 times 11 is 1,331. So I'm able to take that out, the 11. And then for my variables, I have j to the 6th, but I'm taking the third root, so j to the 6 over 3. And then I have k to the 12 over 3. So this will simplify to 11j squared k to the 4th. And that's my final answer. Alright, looking at number 14, I have the 4th root of 81 squared. So like I tried before, actually on number 11, first I'm going to see if I can find groups of 4 within 81 and then just square it at the end. If that doesn't work, I'll square it first, but I want to see if this works because I'll save myself some work if I do it this way. So I know 81 is a perfect square, 9 times 9, and 9 is a perfect square, 3 times 3, and 3 times 3. So I was able to make a group of 4 within 81. So I take out my 3, but I have to remember if I do it this way that I still have to square my answer at the end. So I have 3 squared, which is 3 times 3, which equals 9. And finally, I have 4,096 to the 1/4 power, which means I'm taking the 4th root of 4,096. Now, I'll be looking for groups of 4 within this number, and it ends in 6, so it's even. So, like I said, I could just divide it by 2, but that's going to be a long way to go. So usually I will try and divide it by a larger even number, like 16, or I could even try 64, and 64 worked. So when I divide it by 64, I get 64 and 64, so it's a perfect square. 64 is also a perfect square, where I get 8 and 8, and 8 and 8. And there I have my group of 4 8s. So I take out an 8, and that's my final answer. So that is all we need to know for our quiz tomorrow. If you struggled with any of those ideas, you can go back and rewatch my videos of the notes. And then I also have silent videos for the skills and the homework pages if you need to go check your answers to the skills and the homework so that you can be ready to turn in your packet